Hello, dear students. This is lecture series about Giancoli physics for scientists and engineers. So, in this lesson, I am going to explain electric potential due to point charge. This is chapter number 24. The topic name is electric potential due to a point charge. Let me explain what is meant by point charge. So, point charge is a charge that has very small magnitude. A charge with very small magnitude. A charge which have which has a very small magnitude is called point charge. Okay, so we have a point charge plus q and we need to determine, I have to redraw the figure. So we have a point charge plus q and we need to determine the potential of this charge. So in order to determine the potential of this charge, we first draw the electric field lines due to this charge. So as we know that electric field lines points radially outward for the positive charge. This charge has the lines that are outward. For the positive charge, the electric field lines going outward. Okay, and so we need to determine the potential due to this point charge. So in order to determine the potential due to this point charge, we assume that we basically, in order to determine the potential, we just bring a test charge of for example, we say this is positive charge from infinite distance to in the field of this charge. So when we bring this charge from infinity to in the field of this charge, so we say that there are different points. So for example, this is point B, this is point A. So because we know that the from infinite the potential is zero at the infinity, and when we bring this charge towards the field of this kind of plus charge plus q, so we have to perform some work done, and this work done can be used to determine the potential of that charge. So because we know that the potential V is work done per unit charge, so we can find potential with the work done that we perform. Suppose, in order to find the work done, we already used another equation, a simple equation, that is potential gradient. So we use formula of VB minus VA is equal to minus E dot dl. This formula is also that says that the change of potential is a line integral of E dot dl. So this is the same formula in order to determine the work done. So we use this equation, VB minus VA is equal to minus E dot dl, this formula. But we know that the electric field intensity E for the charge is equal to 1 over 4 pi epsilon naught q over r square, or E is equal to k over r square. So this is formula for electric field intensity E. So we put this formula intensity E in this equation, above equation. So I have to write again VB minus VA is equal to minus integral RA to RB, and then we have to write q over 4 pi epsilon naught 1 over 4 pi epsilon naught q over r square, 1 over r square into dr. Okay, now we can simplify minus 1 over 4 pi epsilon naught or minus q over 4 pi integral 1 over r square into dr. So we took separate integral 1 over r square dr. So r power minus 2, we use power rule. So integration, it can be solved separately. So r power minus 2 plus 1 over minus 2 plus 1. So we are left with the minus 1 over r power minus 1. So minus 1 over r. So r a into r b. Okay, so we can find minus 1 over r b minus 1 over r a. R b minus r a. R b minus r a. 1 minute. Okay. So minus, we can remove the minus by so this is 1 over 4 pi epsilon naught q over rb minus q over r a, rb minus r a. Okay, so this negative sign can also be removed by taking because we know that rb minus ra, so q 1 over rb minus 1 over ra. So because this is minus and this minus can be cancelled with this one, this negative sign, so that it becomes positive. Okay, RB minus RA. So when we put this formula, instead of this value we put 1 over RB minus RA, so we are left with the, here I have to write VB minus VA is equal to, VB minus VA is equal to 1 over 4 K over 4 pi epsilon naught, K over 4 pi epsilon naught 1 over RB minus 1 over RA. Okay, so suppose our B point is taken as infinity. So as B point is taken as infinity, suppose this point B is at infinity, so that if B is infinity, so V infinity becomes 0, potential at infinity will be 0, then 1 over RB also becomes 1 over infinity becomes 0. So we are left with the VB minus VA, which is equal to K over 4 by epsilon naught, so this is 0 minus 1 over RA. So this VB is also 0, VB is also 0, so we can write 0 minus VA is equal to, so this negative sign, so because this negative is also removed, here we have negative sign, so this negative become positive, so VA is equal to 1 over 4 pi epsilon naught Q over R RA. So if we remove this A, so we are left with the VA is equal to 1 over 4 pi epsilon naught Q over R. So this is the formula for potential. So we move with the VA. So V is equal to, so this is negative sign, this is negative sign, which can be further removed by the, this is negative sign, this is negative, okay, this is negative sign, okay. So this is the potential, formula for potential. Okay, now we explain, basically this formula says that the potential V is inversely proportional to distance R. You can see that as we move away from the charge, so the potential decreases, potential when as we move from the away from the charge, potential decreases. So if Q is positive, for example, if Q is positive, charge is positive, so its potential is large at the surface, at the near the surface of the charge or near the charge, and when we move away from the charge, so that its potential decreases. So the graph, this graph shows the behavior. So basically if you draw the graph between potential and the distance R, so the near the charge potential is maximum, the potential is maximum, but when we as we increase the distance R, as we increase the distance R, the potential decreases, it's inversely proportional, means the potential decreases as we move away from the charge. For example, this is point charge, as we move away from the charge, so the potential V decreases, because as R increases, the potential V decreases. Okay, if the charge is negative, for example, if Q is negative, if Q is negative, then if Q is negative, then the same behavior, the potential is negative at the surface, potential is maximum but negative maximum. Suppose potential is, for example, for the positive case, the potential is 200 volt, for example. So as we increase the distance, it decreases, but when the charge is negative, so its potential is, for example, minus 200, it's a negative, that is minus 200 volt, but when we move away, so that this charge decreases to 0 at infinity. So that's why the graph is like look like this. So it's a maximum, V negative maximum, minus maximum, but when we move away from the charge, so it decreases and until it becomes very 0, close to 0, means decreases. Okay, so I hope it will work. The potential V is inversely proportional to again R. If Q is negative, the same potential is negative, but it decreases as we move away from the charge. Okay, so if I summarize this, so it means if we have a point charge plus Q and we need to determine the potential due to this point charge, so we bring another charge in this field, so we have to perform some work done. So the formula for work done is VB minus V is equal to minus integral E dot dl. So this formula is also the work done, equation for work done, that shows that the change of potential depends on the electrical intensity and the length element dot product dl. So it means though, so we know the value of E is 1 over 4 by epsilon Q over R square. We put this value and we integrate and we solve integrate and we get the value potential V is equal to 1 over 4 by epsilon naught Q over R. Okay, this formula shows the potential